So the relative error, as you can see on the board and in the packets in front of you, is the discrepancy between an exact value and some approximation to it. Does everybody know what discrepancy means? Right? Discrepancy means the difference between these two values. So the way we're going to measure it is the relative error is equal to either our measurement or our guess. Estimate means guess. Minus the actual measurement divided by the actual measurement. These two bars here are the absolute value. I know you've seen them before, but just to remind you, it means that it's the distance away from 0. So that number is always going to be positive. This is going to give you a decimal. That decimal is going to tell you how different you are from the actual answer. So we're going to do a quick example to help explain this. Everybody knows who Bart Simpson is, right? Everybody knows Bart Simpson. So we're going to guess how old Bart Simpson's character is.
Oh my God.
So as a class, we have to come to a consensus about how old Bart Simpson is, so we all have the same guess written down on our papers. So who wants to guess how old Bart Simpson is? How old?
8.
8? You think 8? Does anybody have another idea?
12.
12? So we have 8, we have 12. So let's vote on it. Who thinks 8? Okay, and who thinks 12? Okay, so 12 has the most votes. So we're going to guess that Bart Simpson is 12 years old. He's actually 10.
I was going to say 10.
Right in the middle.
I'm going to say 10, right in the middle, right? We took the average, we did the right. But so how do we do, what's the absolute value of 12 minus 10?
2.
2. So this is going to become 2 over 10. And we know how to do that as a decimal, right? How do we do 2 over 10 as a decimal? Can somebody tell me?
0.2.
0.2. So we can say our relative error is 0.2. We can also represent our relative error as a percent. Does anybody know how to change it to a percent? Has anybody done that before? Yeah?
You can multiply it by 100.
When we multiply it by 100, we can put another 0 here, and we move this decimal point over 2 places. So what are we going to get as our percent?
20%.
20%. And what is this percent measuring again?
Relative error.
Right, our relative error, so it's how wrong we were almost, right? It's how different. If we had gotten a smaller percent error, if we had gotten like 10%, what would that mean?
We were closer to the actual
We were
answer.
closer to the actual age. And what if we had a 50% error?
We were way off.
We were right, we're not very good at guessing.
Really bad.
We're not very good at guessing if we have a 50% error. What do you think would happen if we had a 0% error? What would that mean?
You're correct.
We're correct, right? We got it exactly right. Okay, so we have some more examples we're going to go through. Everybody knows who this is?
Lady Gaga.
Lady Gaga.